You good? All right. All right, thank you for waking up by 10 a.m. Sunday morning. I know that's not easy at DerbyCon at security conferences. But today we're going to talk a little bit about how to get Windows to play with itself, a hacker's guide to Windows API abuse. My name is Brady Bloxham, founder and principal security consultant at Silent Break Security. Real quick, a little bit of background on me. I started out in the government space working for various three-letter agencies. And originally what I saw that there was a big gap between what the private sector considered a penetration test and, some of the offensive attacks that, are performed in the real world, right? So I decided to, take what I learned from the private sector and apply it to, the public sector, working for, the government and DoD, and apply it to the private sector. So that's kind of how this all got started. A lot of the research, was done on my own time. And Throwback, the tool that I'll be talking about, was also developed and is used a lot on a lot of our penetration tests. So for anyone that's familiar with the PonoWest project, also started that. So yeah, let's go ahead and jump right in. So first off, a little bit of background. Yeah, before we get into the danger zone, everyone brace yourselves. Ultimately the goal of the talk is to shorten the gap between a penetration test and an actual attack. Again, going back to what motivated me to leave the government in the first place. So who has heard of H.D. Moore's Law? Anybody heard of that? I know Bryce talked about it in his talk yesterday. So yeah, it's basically a phenomenon that says, or the law that says, that the casual attacker will grow at the rate of the capabilities behind Metasploit, right? So who in here wants to penetrate, do pen testing at the rate of a casual attacker, at the rate of, like a script kiddie? So the idea then is to, to raise our level, so we're kind of going beyond that level and applying some custom attacks, using custom tools, and doing more advanced stuff, ultimately to provide customers, clients, people in the private sector with a better perspective of how well they do against not a casual attacker, but more of a targeted type attack. There are other projects that do this as well. I think Cobalt Strike does a great job of it. The Veil framework, a lot of the stuff that's coming out for PowerShell also does. So, while Metasploit does a lot of great things, I think it's always helpful, to constantly try to improve as well. So, I've also seen that there are very few persistence tools, open source tools and techniques available. So, as we go throughout this, a lot of this talk will be on persistence tools. So hopefully, you guys will be able to use that in your penetration tests. I've actually been really impressed at DerbyCon. There's been a lot of talk on red teaming, and I think that's really cool, because normal pen testing is kind of lame, right? So we have a lot to cover. We're first going to talk a little bit about DLL injection, then we're going to go into some persistence techniques, then I'm going to go over Throwback, how to use Throwback, and there'll be tons of demos along the way. So if you have questions, comments, feel free to raise your hand throughout the presentation. So first, DLL injection. There's a lot of traditional methods, and out of all the ones that are listed there, the only one that is actually documented by Microsoft is create remote thread. If you go and do a search for any of the others on MSDN, none of the other ones will show up. There's NT-create thread EX, which personally, I have never had any luck with that. It is like super sketchy. RTL create user thread, that's usually my go-to. It usually works really well. The one that is documented, create remote thread, because it's documented, Microsoft has put so many protections around it throughout the different versions of Windows that you never really know how it's going to react in XP or Windows 7. Like, it doesn't work very well in Windows 7. Because of different integrity levels of processes, but in Windows 8, I read on Stack Overflow that people are getting it to work fine. So because it is documented, there's more protections around it. Typically, my go-to was RTL create user thread, and the last one, NTQ APC thread, can even blue screen boxes. So wouldn't it be nice if, if we had another technique to use for code injection or getting our DLL loaded? There's also code caving, which is also, it's a really awesome technique. It's basically where you start up a process suspended, you overwrite EIP of that process with, the instruction pointer to where your shellcode is, and then you resume the process. So it's a really cool technique, but it's not nearly as easy on 64-bit OSs. So that's a huge limitation in my mind. So the API that I found, it's called Add Monitor. And first off, a little bit of background on Add Monitor. We're going to be picking on print spooling a lot today, okay? So Add Monitor is a function that installs a local print monitor and links the configuration. So, in Windows, you have your driver, you have your print driver, right? And basically what the monitor does is it monitors for, jobs, data, whatever that, user space needs to pass on up to the print driver in kernel space. So there are some limitations behind this. The limitations being that, first of all, in my mind, I think the big one is the DLL must be on disk. And it also requires administrator privileges. So if you're, in a situation where you can work around those things, then Add Monitor is a great alternative to, load library or one of the other DLL injection techniques that we talked about. It injects into spool SV, so you really don't have a choice on what process your DLL gets loaded into, but hey, your system, so you probably don't really care anyway. And it also doesn't require matching architecture. A lot of the, the DLL injection techniques, the DLL has to match, whatever, has to match the architecture of the OS. In this case, that's not true. So it's super easy to use. In fact, yeah, let's do a demo. Let's see. Yeah, so this I just made a video for because I'll be honest, it's just not as cool as some of the persistence techniques. So first I just create the structure. The arguments that it takes is just it's like an LP byte, or no, it's a monitor structure, monitor info2 structure. And so you just have to build out that structure with the DLL that you want to inject, or that you want spool SV to load. You have to tell it whether it's a 64 or 86 or 32-bit. And then really it's just a matter of calling that API. So it's super basic. It's not difficult at all. And then your DLL, will get sucked into spool SV, and from there, you can do whatever you want, your system. So in the demo, I'm using, just a very basic DLL. All it does is when it gets loaded, it just does output debug string of, some various strings. So what I'm going to do is I'm going to start it from the command prompt. So you'll see me type it out. You'll see the DLL get loaded under spool SV in Process Explorer. And then I have the debug view window pulled up so you can simultaneously see that, that our DLL is loaded and that it's printing output there. So we should see in Process Explorer the green one pop up. There's our DLL inside spool SV. And then I think I switched to the debug view window so you can see, yeah. Oh, actually, no, sorry. So in this case, actually, I used, it was just a hash dump DLL that I made that injects into LSASS and dumps all the hashes. So in this case, you have, your system. So from spool SV, you can inject into any other process or migrate into any other process. And I just did a hash dump on that box. So, okay. So let's move on to persistence. In Windows, what persistence does everyone use in Windows? If you're on a penetration testing persistence, what do you use? Service, okay. Auto run keys, SCH tasks, okay. Start a folder, okay. So, there's tons of persistence in Windows, right? If you want to be cool, maybe use the app init, registry key, but even that's being monitored pretty heavily by AVs. So and to be honest, there's still tons to find. I mean, Windows is full of like DLL hijacking techniques and things like that. So there's all kinds of persistence techniques in Windows, and there's a few that we're going to be talking about today. The techniques that I used to find them was process monitor and hooking load library. So if you start up, WinBag and just hook the load library API, then every time any process calls load library, you can see what DLL it's trying to load, and then you can see if that DLL actually exists or not. You can do essentially the same thing through process monitor. You just can't do it as well on boot up. So, and actually in a little bit we're going to just real quickly go over process monitor, how to use it. So this is just a screenshot of process monitor. I know you probably can't see that very well. Again, we're going to have a demo of it, so we'll cover more of that then. So the first technique was actually kind of a funny story. It wasn't very funny at the time, but I found this technique using VMware tools, probably like, I don't know, a year or two ago. And basically all you have to do is drop either of those two DLLs, TP-Genlic or ThinMon, in that directory. If VMware tools is installed, which is on a lot of boxes, if the organization runs VDI, any sort of virtualization, these DLLs will get loaded on boot. Awesome persistence technique, right? No registry modifications, nothing. Pretty stealthy. So DEF CON rolls around and I'm preparing, my talk and decide, hey, I better test this for the demo. And VMware patched it in ESXi 5.5. So I was running around crazy, trying to figure out what I was going to do. So it ended up not being a big deal. I just found another one, within VMware tools. So like I said, there's a lot of these out there. This is the latest one, and to be honest, there's probably more. It's just ntdsapi.dll, same directory. Drop a DLL there, VMware tools is installed, this DLL will get loaded into VMware tools, the system process on boot, and there's your system level persistence. So again, pretty stealthy. The idea is to be as stealthy and covert as possible, to emulate an actual attacker. I guess the only limitation is that the DLL has to export the same functions as the real NTDS. So just look at which functions it exports and be sure to export the same ones. So, yeah, so let's do a demo on this one. This one's kind of cool. So let's see, this might be kind of tricky. Oh. I can't see. Okay. So this is the DLL where when it gets loaded, it'll just do some output debug strings. So we're just going to drop it into system32, WBEM, WBEM folder. NTDS API. So let the VM reboot. When the login screen comes up, I'm going to log in as fast as I can. So because it's getting loaded as system, right? So it doesn't actually wait for the user to log in. It's loaded up and running within vmtoolsd.exe. So the DLL only prints, like 10 strings. It only runs for like 10 or 20 seconds. So that's why it's kind of a race condition on login. Okay, and it should be loaded. It's not that. There it is. So you can see it calls the run counter API. It's running from process 1180, and then it just does that loop for like 10 or 15 seconds. So if we start Task Manager and want to see what process 1180 is, it is VM Tools D. The only thing to be aware of is that sometimes there is a user process or a VM Tools D user space process. So you just want to add, some logic to your DLL that, hey, if this is user, then just exit out. You probably don't want persistence as a user. So yeah, that's the first persistence. And I'm going to delete that because, oh, that's right. Yeah, so Windows won't let you delete a DLL that's being used, but you can rename it. So it's kind of a cool trick. Okay, so in case you haven't noticed, really what we're doing here is we're going from good, better to best. Okay, so now we're moving on to the best. This is the persistence technique. And we're still picking on print spooler. And it's actually very similar to the DLL injection technique of add monitor. Basically what we're doing is we're adding now a registry key to get our add monitor DLL loaded on boot. There's some really cool things we can do with this. Okay, this is the location in the registry. And all you have to do is create a new key with a new value named driver. And then the name or the string value, have it be the name of the DLL. So the DLL has to be in system 32. So that's why you don't have to list the full path. You just say the name of the DLL. The awesome thing about this is you can add as many as you want. You want 5 persistence techniques or 5 DLLs to be loaded at boot. You just add 5 folder or 5 registry keys, and then each of them with a value. And I should have quit Skype. So yeah, so let's test this out because this honestly is a pretty cool technique. So another demo. Okay. All right. So we're going to use the same DLL. So it's just going to do some output debug strings. Nothing too fancy. But then in a minute, we'll test it with an actual backdoor and see how it works. So I codenamed it Aramis a while ago. So you hit Aramis, and let's see, we'll just call it, let's see, DerbyCon. DerbyCon.dll, okay? And then it asks if you want to load it now, and we'll say no. Okay, so, and then you have to copy the DLL to system 32, that's right. Okay, so now let's go into the registry and see what that did. So the demo executable that I created, it creates the key called fax monitor, and there's our driver, and it's just DerbyCon.dll. So let's, just for the heck of it, let's do another one, okay? Let's do another key, and we'll call this like, what should we call it? What we'll call it, White Lightning. Okay, right click, string value, you have to name it driver, and then we'll call it whitelightning.dll. Okay. All right. So now we'll reboot the box. Again, after it boots up, we're going to pull up debug view as fast as we can so we can see that both those DLLs, so now we should have 2 of those DLLs be loaded on boot and have persistence. The DLLs are still getting loaded, in this case, within spool SV, just like the add monitor. And there they both are. WhiteLightning.dll and DerbyCon.dll both get loaded. And then they run through their loop 10 or 15 times and then quit. But again, obviously, you can customize the code to do whatever you want. I get the SE debug name privileges just to show you that, hey, we are system. And the SE restore name, basically means the same thing. So those are the 2. Thanks. So yeah, that is another persistence technique if you want to use that instead of just the generic services, which is pretty much what everyone uses, or SEH tasks once they get system. Much more stealthy, I think. So let's go ahead and move on. Before we talk about the release of Throwback, I wanted to first go over really quickly just kind of a Windows API HTTP cheat sheet. A lot of people bag on Windows programming and the Windows API. Personally, I love it. I think it's awesome. It makes doing a lot of what would be complex tasks, for the most part, pretty easy. So there's 2 libraries or 2 APIs that you can use in Windows. The first one is WinHTTP. The other one is WinINet. For programming in C or I guess PowerShell or .NET or anything for that matter. For HTTP traffic. And I'm focusing on HTTP because, if you want to get out of a network, that's typically how you do it. So WinHTTP is intended for services, so it doesn't have a lot of the proxy robustness that WinINet has. It doesn't pull user proxy settings automatically. However, since it is a service, it does support impersonation and, some of the stuff that services would normally perform. WinINet, on the other hand, like I said, it is much better for a proxy environment. For doing something as complex as I want to get out of this network that has NTLM authentication at the proxy, it's one flag that you set within an API call. Has anybody ever noticed that Meterpreter has problems with NTLM proxy authentication? I set up a lab and noticed that, hey, I couldn't get a Meterpreter callback, because I had set up NTLM authentication at the proxy, and I go and look at the Meterpreter source, and it's because they're missing that one flag. So adding something as complex as NTLM authentication at the proxy is as easy as, hey, add this one flag to the API call, and boom, in the back end, behind the scenes, Microsoft will take care of the rest for you. So it basically uses the IE settings, WinINet does. So I explain that so you can kind of better understand, I guess, my thinking when I built Throwback. Throwback is it was written in C++. It's an HTTPS beaconing backdoor with a PHP control panel that's written, that's written in PHP and MySQL that runs on Apache. So it was built primarily for stealth. However, don't look at the code because then you'll see probably like buffer overflows all over the place. So it also has persistence built in. The DLL persistence, it's super easy to utilize the DLL persistence that we've already talked about. And then as an exe, it persists as most exes, which is as a service. It'll install itself as a service and persist that way. So let's go a little bit deeper into Throwback. I guess I built it, just again, feeling that, penetration tests need to be modeled after real-world attacks, and there really isn't a backdoor out there that can be used, for stealthy persistence. So this is essentially how it works. You can install the throwback LP, as I call it, on multiple servers. And then throwback, or the infected box, in this case, the attacker sends an email to the target. Throwback is embedded in the email, or, as we're actually going to do, we're going to infect a box through reflective DLL injection using a Metasploit exploit. So however you decide to get throwback on the box, it then beacons through HTTP and HTTPS out to your throwback LPs. So that's, at the most basic level, that's how it works. Some cool things about it, though, is if you remember, I compared when HTTP and when INET. When HTTP is for services, right? So I actually decided to you can use WinINet in a service process, but it just doesn't pull the proxy settings very well. So the approach that I decided to take was, I'm going to use WinHTTP, and then if it's running within a service and it can't get out, if it can't get out through the internet for whatever reason, maybe they have, explicit proxy settings at the user level and it's not set for the system. So what throwback does is it enumerates all of the users that have logged into the box, finds their ntuser.dat file, mounts that manually, finds their proxy settings within the ntuser.dat file, and then uses those proxy settings to get out. And it will loop through all of the users essentially until it can get out. So the areas that WinHTTP has lacked in, I've tried to add some robustness there. Another cool feature is on the LP side, you can add multiple LPs. So typically how we use it on our penetration tests, is again going for stealth. We'll set up 5 or 6 different LPs, throwback LPs, and what throwback will do, once you implant a box, on whatever your configurable callback period is, it will randomly select one of those 6 LPs to call back to and see if there's any tasking for it. So it's not always calling back to the same domain, it will randomize that. Or if you want to go linear, then you can choose to go linear. But you can add multiple domains. It also uses MSGRPC. Bryce Kuntz built a really easy to use MSGRPC library for PHP. So basically what you do on the LP is you fire up MSGRPC, the PHP will interface with MSGRPC to create Metasploit payloads that you can then deploy to your target through throwback and inject into memory if you want to get like a interpreter shell on the box and go interactive. It also has RC4 encrypted comms, so even if you are using HTTP, the communications are encrypted. It implements reflective DLL injection, both as a DLL and as modules that you give it. And there's also string encryption. So for basic reverse engineering, if someone finds the DLL and just runs strings on it, then it's not going to, dump out all of your LPs. They'd have to reverse engineer it. So here's what the interface looks like. So let's go into it. Let's do it. All right. So what we have. Okay, don't need that anymore. And actually, before we do this, I need to delete these other persistents. So let's delete. Oh, yeah, that's right. Those ones aren't. Let's see, and what did we name the other one? Oh, DerbyCon, that's right. Okay, so right now we don't have any persistence on the box, just deleted all of them, right? So for this demo, what we're going to do is we have our Windows 7 box here. And here is just a This is just a Kali box. Okay. So what I'm going to load here is this resource file. That's just going to, we have an internal exploit. It basically leverages a public vulnerability. We just updated the ROP gadgets for the version of IE that we're going to be using. We creatively named it 2 Girls, 1 Exploit. And so we're going to load this resource file. Notice for the payload, we're going to use the DLL inject payload because we want to use throwback with, as a payload. We don't want to use Meterpreter. Again, Meterpreter has, some egress restrictions, and, so let's just say you want to get persistence on the box instead of, just trying to use Meterpreter. So, that's what we're going to use. You'll also notice that even though it's a 64-bit system, I use TD32. That's the throwback DLL, and I did that because there's no 64-bit payload of DLL inject. And besides that, IE actually runs as a 32-bit process anyway. So, let's see, what is it? Derby. Yeah, there we go. Okay, so there's all of our exploit. Okay, so now we'll come back to this box. And here we have our throwback LP. So it says no targets, get to work. So as soon as we exploit some boxes, we should see them pop up there. So let's go ahead and we're just going to navigate there. Make it easy. 20.110. Okay, that should be it. In the background, you saw the text flyby sending the stage. So at that point, it pushed up the, the stager for the DLL inject, which also did a reflected DLL injection on the throwback DLL. So in a second here, hopefully we'll see a box pop up. There it is. So IE template. You can see a few things, in terms of the icons. If this icon means that it's running a system. This icon means that it's a direct connection, so it will tell you whether or not there's a proxy, and the icon will change if it's a proxy. That tells you what version of the implant you're using. I did that just because I was making so many revisions to it. Target name, so you can change the target. We can call it Derby if we want, whatever. The callback period is set to 1 minute. That's just the default callback that I made, just so we could do some cool stuff with it. So, and the last callback was, not very long ago. Okay, so we're on the box. What's the first thing we want to do when we're on the box? Come on, guys. What's the first thing you want to do when you have access to a box? You want to get a shell, right? Well, or persistence, right? So we're going to do both of those. Okay, let's get a shell first, though. So to go interactive, you just click Met Creator. In this case, we'll do we're just going to do shellcode injection. So let's use a reverse HTTPS. That's the HTML file that it's going to create. What it does is it creates the shellcode and then base64 encodes it. And we want the IP that it is going to call back to is 20.110. And then just hit create payload. Okay. So it was successful, so it gives you a little pastable here. So, for you lazy people, Bryce. You just come into here, paste it, our handler's set up. Okay, and we're going to cheat, all right, because technically what you could do is, run like a task list to get the PID of the process that you want to inject into. But I'm just going to cheat and just look at the PID. Let's inject into Notepad++. So 2616. So we'll come back into here. This is the HTML file that we need to tell it to download for the shellcode. Download and inject shellcode. And then 2616. And just for the heck of it, we'll do like get process list. If you have multiple targets, then you could add a task to multiple targets. You just click each one that you want to add it to. And to be cool, we'll pop calc too. I think. And we need to keep an eye here. Oh, our interpreter session's already there. So what it did in the background, then, because it calls back once a minute right now, that's how it's configured. So when that minute hit, it called back, it grabbed the HTML file, base64 decoded the HTML or the shell code, and then injected it into Notepad. So if we do like a get PID, we're 2616, we can now get privs and, essentially do whatever we want on the box. Okay, great. So one of the other things we want to do is, someone mentioned get persistence. Okay, so let's do that. So let's download file. In this case, we'll call it tb64.dll, which is just a 64-bit version of the throwback DLL, and we're going to put it in system32. We'll call it just throwback.dll. Okay. That looks good. Oh, I forgot to select it. Okay, and then in this text file, to make it easy, this is how you add the, oh, whoops, I should have named it ponage. Oh, that's all right. Let's change it. So this command is basically going to add the registry keys that we need to maintain persistence. So we called it throwback.dll. And again, it's, in this case, it's fax monitor. Okay, so we'll submit that. There's our calc. Okay, it already downloaded our throwback DLL is right there in system32. And if it's not here right now, it should be very soon. Nope, it's not there yet. So it must, you can click on history and see the results. So yeah, so it hasn't called back. It's waiting for delivery. The throwback DLL download was successful. Here's our process list. You can go back and see the results of all the tasks that you had queued up and that it's executed. So if you click on history now, that should be done. When it calls back once, it will call back until all of the tasks that it's called back to complete are done. Actually, I may have missed it. Oh, nope, there it is. So it's done. So if we go into it now, yep, there's the new registry key with the driver, throwback DLL. And our throwback DLL is there. So just to test it, let's restart. What do you mean one session? Oh, yeah, so what it does was like each time that it calls back, it establishes a new HTTPS session. So it's not like one continuous, it doesn't like maintain the HTTPS connection. It's, again, it's kind of designed for stealth, so it's not going to, stay connected for lengthy periods of time. It calls back once, however often you tell it to. So in this case, I set it to a minute. And as long as there's tasking, it will continue to call back and complete each task. If there's nothing, then it just calls back once, for the minute, and then it'll call back again the next minute. So last time it called back was 8:39 a.m. Obviously, having it call back once a minute is horrible OPSEC, right? And it just called, you can see just the last callback was just updated, so we have persistence, the target's still calling back, and we still have control over it. It's running the system. So yeah, if we wanted to have better, OPSEC, then we would probably change this depending on whether or not we wanted to use it or go interactive. We could change this to like, 60 minutes. So in a minute, it'll call back, see that you want to update the callback timeout, update it to 60 minutes, and then it won't call back again for an hour. And some of the other tasks, some of the other things you can do with it are it has the upgrade functionality, download and execute shellcode, which we used, download and execute DLL, EXE, obviously you can run any command, netstat, do things like that. So in terms of functionality, it was intentionally made, to be small and to be stealthy. For functionality, typically you want to use a full-blown RAT, like Beacon or Interpreter or something like that. So I have started to add in, the ability to add modules to the LP. So if you have like your own custom reflective DLL that you want to deploy to the box, such as like a keylogger or a custom backdoor that you can, that's just a reflective DLL, you just add it as a module, and then you come here to deploy module, and there's no modules found, so it's not going to deploy it, and then you can inject that module into a process. So, that's probably the best way to extend functionality, is just through modules. So going forward, obviously it's a community project. It's available now on GitHub. Like I said, I've already started to create some of the modules, but keylogger, Mimikatz, hash dump, things like that, they wouldn't be very hard at all. You just have to create them as a reflective DLL, which is already included in like the Metasploit project anyways, and then you just deploy it through the interfaces we saw. Additional persistence techniques, I think it'd also be cool, and then modification of comms, obviously, so if it's flagged once, it doesn't continually be flagged, you can make it more malleable, which is a cool feature of Cobalt Strike, I think. So, the end / shameless plug. If you're interested in writing these types of backdoors and custom malware, even like taking other people's custom code and tweaking it for your own purposes, we'll have a training. It's called Dark Side Ops, Custom Penetration Testing. It'll be at Black Hat Europe and East Coast trainings. So, we don't really focus on, you don't have to be a C expert. I'm definitely not a C expert. It's just, a lot of it is just tweaking what's already out there and what's openly available to you to create something custom, to use it for, a customer that, may want more of a real attack. Another cool project is Black Squirrel. I'm involved in that. And again, Silent Break Security. We do a lot of black box / red teaming pen testing. So without any questions? Yeah. For what? You mean like for persistence? Like why did I focus on print spooler? I focused on print spooler. I was actually just kind of looking through MSDN, as I like to do in my spare time. And I just found, like these different add functions, and there was like an add monitor, delete monitor, and that's just kind of what got me started going down the rabbit hole. And Spool SV is an older process, so I figured, hey, there's probably a lot of legacy code in there. It's been around for a long time, so printers have been since like Windows 3.1, even before that. So I figured that might be a good place to look for persistence and maybe for some APIs that could be abused. So that's what initially started it. There's no doubt that there's other similar APIs within Windows. Windows is kind of a black box when it comes to a lot of its APIs, especially the undocumented ones. So yeah. Yeah, it works. Yeah. Yeah, so the traffic is all RC4 encrypted, So even though it's within an SSL tunnel, it's RC4 encrypted and base64 encoded as well. And so they would have to have something extremely custom to, to detect that type of traffic. And it's all done through, generic looking posts and gets anyways. So it was designed, to look as normal as possible. Yeah, I mean, in terms of what, Throwback's gone up against, it's gone up against, FireEye, a lot of, really expensive, vendor tools that are supposed to catch this kind of stuff, and it flies right by it. So we use it on pretty much every engagement that we do. So it's pretty effective at getting out of networks. Yeah.
The first persistence method we did, DLL hijacking, what do you use if they don't have VMware tools installed or something?
So the last one that we demoed, the one just now, that works for anything. So that has zero limitations. It works. I haven't tested it on 2K12, but I know it works on Windows 8, so I'm guessing it works on 2K12 as well. So all you have to do is install that registry key, add the driver with the string, with the value pointing to the DLL, and you have system persistence. So there's no limitations on that. Any other questions? All right, well, thanks guys for coming. Appreciate it.